Hi everybody, and this is the video for the quiz on activities 6 through 8 for pre-calc. On the quiz there are 14 questions, 3 on the non-calculator part. So that leaves 11 other questions. So of the 11 on the calculator, 2 are multiple choice. Everything else, obviously, you'll write down your answer. So as you can see, that on the non-calculator portion, there's a lot of drawing graphs. That includes one where you're given an equation. So with this first problem, the idea is that you can draw a graph exactly perfect without your calculator. So with this information, we know that it reflects over the x-axis due to the location of the minus sign. The -3 means it moves right 3. And the 4, of course, on the outside means up 4. Now, the order that you do this really matters. You have to do this in the x, which is left or right. Then you have to do a horizontal shrink or stretch, which we don't have. Then you have to reflect it. And then you're going to move it up. So then we do the y, which is up or down, but obviously we have up. So if you think about where the parent function exists, square root 0, 0, 1, 1, 4, 2. If it helps you to draw those on there, we'll put them on the graph. 0, 0, 1, 1, 4, 2. So here's the graph before we do a bunch of stuff to it. So the first thing we have to do is add 3 or move 3 to the right. So we're going to add 3 to the x's. Or you can physically count each point to the right 3. Your choice. So now we're at 3, 0, 4, 1, and 7, 2. So we're right here. I don't know if we have 7, 2, do we? We sure do. So here we are. Now, when you reflect this around the x-axis, you change the sign on the y. So that makes those negative. So now we're just down here. This is the new graph. And then we have to move each one of those points up 4. So that means on the y, we're going to be adding 4s. So this one moves up 4. So we are at the point. The final points, 3, 4, 4, 3. Remember, we're going to move it up here, so it's going to be that same pattern. And then we're going to have 7, 2. So we're over 7, up 2. So this red one is the final graph. So I tried to do it 2 different ways all at the same time. You can either count the squares or you can mess with the arithmetic from the table, but that's going to require that you know the table. So the points should be plotted exactly, and your graph should look good because you have 3 points. You don't need to have more than that. You can if you want to. Drawing a function that is even, this is your choice. So just make sure that it is symmetry with the y-axis. So you can draw one that you know, like absolute value. You could draw the parabola, or you can make up your own. But just make sure it is perfect symmetry with the y-axis. Don't go crazy. Number 3 is not even or odd. So you want to make sure that there is no symmetry with the origin. So avoid the origin. Just don't go through the origin. Don't let it touch the origin. And not symmetry with the y-axis means maybe you go crazy on one side. You know, maybe one side of your graph is like all this. Don't go through the origin. And then the other side is plain. It doesn't really matter. Just make sure that when you fold it in half that it doesn't match up. And that is all the non-calculator questions. So expect even and odd questions and expect to have to draw a graph where you're given numbers. Now for the calculator portion, it does start with a piecewise graph. Remember, you will have your calculator. So if you put y equals absolute value, remember it shows up ABS on your math. Some of you have the absolute value bars, and then you would have 2x plus 2. If you go to second graph, this will give you the table of values. And you can pick any table, any values you want. So here we have to start at 0, and we have to go smaller than 0. So if you look at the table, it says 0, 2, or you can plug it in yourself. We have -1, 0, and -2, 2. That should be enough to get this first piece going. This is all from this one. This is all just this first part. So 0, 2, -1, 0, -2, 2. So it does look like an absolute value graph, which is good. Been chopped off though, so it's not the whole graph, but it does go on forever to the left. Now for the next graph, if you want to put it in the calculator, that's up to you. This is a line. So we know if we plug in a 0, we're going to get 0, 1. Now 0, 1 is not currently on the graph. This one is open because there's no line underneath the symbol like the first one. So 0, 1 is going to be open. And your slope is 2/3. So I'm just going to count with the slope. So from our open circle, we're going to go up 2, to the right 3. You don't have to do it that many times. I just did it because I can't draw a straight line. And so that's what the graph looks like. It's not actually continuous. There is, I'll zoom right in here. There's a giant space between these 2 points, between 0, 1 and 0, 2. All right, so then for the next one here, even odd or neither, you can put it in your calculator and take a look at the graph. I'll just draw a little sketch on here for you. You certainly don't have to draw it, but it goes up 3. It's absolute value, and it's got a vertical stretch. It is even because when you fold it in half on the y-axis, it will line up perfectly. So remember, you'll have your calculator for that, and you can just look at it. Now, this next one is worded kind of weird, but just go with it. There's one like this. There's one like all of these on the quiz, so this is everything that you'll see. So we're starting with x to the third plus 1. It's weird that we have a plus 1 there. And then we have to do a vertical compression by 1/3. So that means that has to be basically on the outside of the parentheses. So you're going to have to create parentheses. And then up 5 means on the outside of the parentheses, the other side, we're moving this up 5. This graph is called g of x. This is not finished, which is why you see the answer written the way it is. You have to distribute the 1/3 and combine like terms. So we have 1/3 x squared plus 1/3 plus 5. Well, 5 plus 1/3 is 5 1/3. So if you want to write it 5 1/3, no problem. You put it in the calculator, you'll get 15 plus 1, you get 16/3. So that is why it says on the answers, it's 1/3 x squared plus 16/3. Multiple choice. So just like you see some multiple choice questions here, there are some on the quiz itself. And so we're going to try to make this graph move to make it even. So I would suggest looking at it on the calculator. So I'm going to draw the graph real quick to show you what I'm talking about. When you look at it on the calculator, it's kind of over here. Even means you want that y-axis to be right here. So we have to move this thing to the right. Up and down, we don't care. It's allowed to be down here. It doesn't have to touch the origin. But all we need to do is move this thing to the right. Nothing else. So this is something we don't want. B, we don't want all this. Looks like C is right only, which is all we need. And D is no good. So I would say this is C, because that's all we want to do is move it to the right. Find the real zero. The real zero is the x-intercept. Real means you have to be able to see it on the graph. No imaginaries. You could also do this with some arithmetic and just plug a 0 in there. It's up to you. You can do it in the calculator. 5 times 0 to the 0.05 power. It's intentionally kind of a weird thing. You could draw the graph and take a look at it, but it does go right through the origin. And behavior. Again, I would suggest you get a little graph on your calculator. I'll just draw it here so we can talk about it. When you set up end behavior, it always starts x goes to infinity, x goes to negative infinity. And then you look at the graph to answer the question. So we're going to split the graph up right here. As x goes to infinity, as we're going to the right, you can see that this end is going down. So that means y is going to negative infinity. As we look at it going the other direction, this way, you can see this end is going up, and that's positive infinity. So when we go to the left, y is going up. Number 10, this is also on the quiz. Now you can see the functions change, and that's how the quiz is as well. So you won't have the same function each time, so make sure you read the directions. Make sure you're going to y equals. Go to y equals and put this in there. So this goes in the calculator. All you have to do is look at the graph. It won't be anything crazy. It'll be like the ones we had. It'll be a parabola, or it'll look like a root of some sort. Those are the only three we've had. There's two kinds of roots, by the way. So this is going to look like this, which it's not really a very good graph of it, but as you can see, it just constantly goes down, 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 down. So this one is always decreasing. If you have that chart that we created from page 100, you might want to just take a look at that and just look at the patterns. That's really all it is a pattern. Now in this next section, we kind of switch here. We get away from the graphs and we get more into the algebra. There are one of each of these. So make sure you pay attention to the order. There's one where it's f of g of x and one where there's g of f of x. So first of all, I'm going to go through and do the domains. This domain, you take this x plus 2, and you say it has to be greater than or equal to 0. So x has to be greater than or equal to negative 2. Every single time we answer the question, that's what we're going to say. Unless, of course, we have something that takes away even more numbers. And then this one, all reals. Second one's all reals, so we're good. So let's do the composition. So this one says, start with f. So f says the square root of something plus 2. Well, inside there, we're going to put in, like this blank right here, we're going to use g of x in that spot, 4x minus 5. We can combine like terms underneath the radical, so we get 4x minus 3. Well, we have something different under the radical, so we have to take that underneath the radical part and say that has to be greater than or equal to 0. Add the 3 and divide by 4, and now we get x is greater than or equal to 3/4. Which you want to pick the one that allows you to have the most restrictive, right? So, or actually, sorry, you want to pick the one that allows you to have the most answers. So this would be, if you think about a number line, I think that's always the best way to do it. So if this is 0, negative 2 is back here. So we're allowed to have all of these numbers. That's a lot of numbers. If you think about where 3/4 is, it's up here. It's on the positive side. So 3/4 actually cuts off some more numbers. It restricts it even further. So we want the most restrictive. We want to give the one that has the least amount of answers. So that's going to be this one. And so we have this answer with that domain restriction. Now the other direction, we're going to start with g. G says 4 times something with the minus 5. And in here we're going to have the square root of x plus 2. Now a square root is like a little protective house. You cannot distribute, you cannot do anything with it. It just stays there. We can't do anything with the minus 5 either. We can't do anything with the stuff under the radical. So we're basically done. And this is the exact same as this one. So our restriction is x is greater than or equal to negative 2. There's one of each of these on the quiz, inverse, and then doing something with an inverse. So we're going to switch the x and y. So x equals 1 over y minus 2. This is the kind, if one side is a fraction, make a fraction on the other side and then cross multiply. So it doesn't really matter which direction you go. So I'm going to go x times y minus 2, don't distribute, and then 1 times 1. Now with this one, because we're trying to get y by itself, and y is trapped inside the parentheses, we're going to have to distribute, because if we divide by it, all it's going to do is bounce around. So unfortunately, we do have to distribute this. Remember, we're trying to get y by itself. So now this guy's got to come over here. So we're going to add 2x. So now we have xy is equal to 1 plus 2x. We're going to divide everything by x. If you do it like that, you can simplify it a little bit, or if you'd rather leave it as 1 plus 2x over x, that's up to you. So if you simplified this and called it 1 over x plus 2, that's fine. Both of these answers are good. It does not tell you to do anything with the domain restriction, so you don't have to say anything about the domain. So one of those two answers is going to work. Now here's a good trick for number 14. We don't want to use the regular function, we want to use the inverse. So think about what the inverse means. It means switch the x and y. Well, normally when we say, f of 12, that means this goes in for x. Well, we're talking about switching it, so put it in for y. You don't have to find the inverse. This is a great shortcut. So the inverse means I'm going to put it in for the other letter. So 12 equals 3x minus 2. So 14 equals 3x. And that's how you get 14/3. I can't get my pages to turn, sorry. All right, so this one has kind of a lot of directions to it. We've done problems like this in class. So we're going to graph this. Now remember, you'll have your calculator, so you won't have any problem getting a very good graph, and you want to get a really good graph. So this graph has a vertex at 2, 3, goes to the right 2, and up 3. And you can see the points right on the calculator, so then it also has the point 1, 4, and 5, 4. So this is our graph. It says state the domain restriction so that our function can pass the horizontal line test. Well, this is where you break it up right at the vertex. So you have to basically pick left half or right half. I'm going to pick the right half. Remember, this point right here is important. That's the point 2, 3. That's where x is 2. So we want to use the x value because it says domain. Domain goes with x. X is greater than or equal to 2. Now that we've cut the graph in half, so basically this part of the graph we're just going to ignore, so it's not there. Now it passes the horizontal line test, and now we can find the inverse. So switch the x and y. X equals y minus 2 quantity squared plus 3. Get this 3 out of the way. X minus 3 equals y minus 2 quantity squared. Take the square root. Now over here, the power, the radical's all gone. And then add the 2. You can put the 2 in front of the radical or at the end of the radical, but this is our inverse. Now we're going to graph that. And then we have to state the domain and range. So if you'd like to do the graph first, because that's easier for you for domain and range, that's up to you. So you can put this back in the calculator, and you get all kinds of points. And we have the point 3, 2. If you can remember the trick in class, you just switch the x and y. So if that one was 2, 3, this one's 3, 2. Then the next one is going to be 4, 3. And then the other one's off the graph because it's over here. It's like something, so you can't really graph it, so don't worry about that. And that's what it looks like. Now the domain for the inverse, the blue one, x is greater than or equal to 3. The range, y is greater than or equal to 2. And finally, this last problem, everyone's favorite, composition. Oh, sorry. Just trying to move this up here. So you're just asked to prove if these are inverses, which means put one inside the other and see if you get the letter x. So it doesn't matter which one you do first, you have to do both, f of g of x and g of f of x. Unless, of course, you get some other answer, then you can stop, because then it says the answer would be no. So if we start with f, f says we have something, a big something, plus 4 to the 4th power with a minus 1. So then g of x is all going right in here, which is a lot. Negative 4 plus the 4th root of x plus 1. Now don't worry too much about the 4th root. Inside the parentheses, remember you have to simplify inside the parentheses first. The negative 4 and the positive 4 are gone. Now we have the 4th root of this radical to the fourth power with a minus 1 on the outside. Well, as you know, when the power and the root match, they're gone. So we have x plus 1 minus 1. That equals x. Now, if we go the other way, we're going to start with g. And g says negative 4 plus the fourth root. And underneath this goes all of f. X plus 4 to the fourth minus 1. And then we finish writing this. We haven't finished writing that plus 1. All of this is under the radical. So it stays under the radical. So again, it kind of feels the same way. The negative 1 and the positive 1 are gone. The fourth root and the fourth power are gone. Now we have negative 4. There's a plus sign right here. It's not multiply. And then underneath there we have x plus 4. 4's are gone. It equals x. So this is yes. They are inverses. So feel free to stop by at any time if you need help during E&I or after school on Thursday. Quiz will be Friday.